morning, good evening, good afternoon, good day, everybody. It's episode 44 of Code Rushed. Roy Becker, say hello.
Hey everybody. It's looking good, looking good.
We're
As
feeling
you say,
good.
episode 44, Lightsaber Walls Part 2.
Yeah, Lightsaber Walls Part 2. Here's the source code over here, where we are, where we left off. I added a little bit of code to add some sparks to this for when the when the drones hit the lightsaber walls. So a little bit of sparking that I put in there. Since I'm talking about it, let's go ahead and grab it and show you so you can see what I'm talking about.
Okay.
Where is my problem? The only problem with having a lot of monitors is, hold on a second. Here you go. The only problem with a lot of monitors is sometimes I don't know where my mouse is. Here we go. So I've got some sparks here, and this is for when the drones hit the walls. So when the drones hit the walls, I don't want them to immediately explode. I want them to shoot off some sparks. And so I've got just real simple animation, only 9 frames long, and it kind of fades out at the end. So it's just kind of like this. I've got them coming from a variety of directions. So depending on where the hit is occurring and the motion of the drone, we're going to go for some sort of a realistic spark effect. Also, there's nothing that is going to stop us from, just like with the paint drips, combining multiple sparks at once to make it look more natural, more unique, so it doesn't look repetitive. So, so that's kind of what I've got there. The code that I added to do that is, let's see where it is. It's in this area right here. So here I'm creating all of these sprites right here. We're loading the sprites by calling load sparks, and it's going out here grabbing firewall/sparks. The folder, oops, the code here I think is wrong. It just occurred to me that I got to put the file name in there as well. So that code wasn't actually working. Interesting. So let's try it. I want to refresh this and try it again here. I'm not actually drawing any of the sparks yet. But I guess what we could do is this. We could do, in fact, let's do that actually. Let's play with the sparks, make sure they're working. I had a function called draw crosshairs right here. And draw crosshairs was called, I commented it out. Let's go look for it, where it is. There it is. It was called at the end of the update screen right there. And so what I'm going to do is I'm going to say draw crosshairs there, and then what I want to do as well is I want to, in my test function here, right now I'm building the walls. I'll show you that in a second, but I also want to throw some sparks out. So if params equals sparks, then what I want to do is I want to do something like this. Uplift and sparks dot sprites dot add dot push. Thank you. Yeah, I always want to go for the add there. Every time I'm here, I think, oh, I really need an add function here. I want to consolidate this and this into a single function of the sprites piece. So I just say add. And then we're going to add a new sprite proxy here. Like that. And starting frame number is 0. And the X and Y is going to be cross X and cross Y. And the lifespan, I don't think we need to, or I guess, I don't think we need to do it.
Surely the spark itself, though, is going to have a lifespan, because although it's going to get to the end of its animation and it's going to be faded out, we're then going to be drawing lots and lots of invisible things as time builds up.
No, I think if I'm recalling correctly, the when we created the up and left sprites, we set the style to, I think, sequential stop. Let's go take a look at this here, just like the paint drips are, right? So what happens is if it's sequential stop, it cleans it up at the end, if I'm recalling, yeah. So,
Fair enough.
or maybe not. No. Sequential stop, it goes to here. It does not clean it up at the end. Hold on. Sequential, I think, let's see if sequential does it. Explosions, yeah, I think sequential, yeah, frame index is 0. So we reset it back to 0. And then we have another check somewhere else that checks to see if it's sequential and the frame index is 0, then we remove it, I think. And let's see if I can find that. Clean up finish animations. There it is. Sequential is what I want. That's the code I'm looking at right there. Okay?
Okay.
All right. So that means what I've got to do is back over where we were. I need to change this to sequential. And I think that's just going to clean up automatically.
Yeah, it's good. I mean, whatever we're doing for explosions is clearly working at the moment, so good model to follow that.
Okay, and then that's it. So now if we do a test with sparks, it'll draw it. Now I'm expecting it to be not lined up with the crosshairs, but I've got the crosshairs and I'm going to actually work on getting the sparks lined up. Later we'll actually make that happen in response to the drones hitting.
Yep.
We'll figure out where the hit point is or where we want the sparks to fly from in the direction. But for now, I just want to get that kind of working. So with that said, I'm going to refresh the screen here with these code changes here. Let's do this. We'll refresh the screen over here, reload the overlay. And while that's loading, I will just quickly show you this. This is where we're headed today. We're kind of going to draw these things. I want to have these thrown up onto screen, these balls. And when they land in their desired position, I want to have them open up. And I've already got the opening kind of working. You'll see that in a second. But what I want to do, here, let's go ahead and do it. So now the overlay is loaded. You can tell the overlay is loaded because of the coins floating around the chat room, the CodeRushed logo at the top. If I type in test like this, just by itself, we're going to get that come in there, right? So there is, and I think we left you, Rory, we didn't have these opening yet. Is that right?
No, we didn't. That was absolutely right. We had a single ball on screen with I think it was a horizontal lightsaber out to the right-hand side. So what you've managed to do is to do all the cropping that was involved in that.
Yeah.
And actually, the animation opening and indeed just statically like that is pretty nice.
It's not bad. It's a static motion, and I wanted to instead do it within a certain number of seconds and accelerate at the beginning and decelerate at the end, so it looks more natural.
Sure.
Is what I wanted to do. I want it to be like rip like that. So and I wanted.
Is this some inherent warbling, sort of randomized movement there for the edges?
Right,
Because
we're
it
using.
seems on the stream like they're moving ever so slightly,
Yeah,
like
it's
unstable.
yeah, it's maybe not a great choice when I think from the standpoint of reducing, creating something that's easily compressed. Creating a stream that's easily compressed because I've got all this motion, but I think it's cool. We added it. It's a jiggle option of the part, and if we go ahead and launch for a second, you can see that the maybe you can. I don't know if you can see this or not. Let's see. Let's do up for 5 seconds. The flames are using it as well to jiggle a little bit.
I see.
Okay?
Yeah.
And it's a subtle kind of thing. And so I was like, oh, let's use it for these too. Because I wanted to make it look like it was kind of like floating and holding itself in position is what I wanted to do. So that's what the balls are doing when they open up. They're like, they've got the jiggle. I don't know if they have the jiggle when they're going to be thrown. I'm not sure if that's going to happen or not. Let's try the test again, this time typing in sparks and see if we see our... Well, I saw that opening again, but I didn't see the params come in here. So that is a surprise to me. I was expecting to see that. Is it, what is going on here? Let's do this. Let's try to think of the best way to solve this particular problem here. I think I want the code to be like, if it's equal to wall, then I want to add the wall like that. And so we don't at least see I want to make sure we're not seeing a second wall. And let's try that. Just see if there's any change at all in the behavior here. So now if we send test out, nothing should happen. And I'm wondering if params is just not getting in, if that's the problem. Let's see what happens if I can actually set a breakpoint here now. So we're reloading. I'm going to type in test sparks. And here we go. Hey, cool. What is params equal to? sparks. Okay. Is it just that I had... Whoa. What happened? I'm hitting F10. What are we in? JS? No, I don't care about JS. I don't want to go here. I'm wondering, oh, you know what happened? I think I do know what happened. So we're stepping through the code, and all of a sudden, where we're expecting to go one place, we go somewhere else. And that's because this doesn't match what it thinks is out there running. So we're not going to be able to use Visual Studio to test this out here. What's interesting is the up, left, and sparks. This should totally work. Let's just double check, make sure that's being added to our sprite. All sparks, and is all sparks drawn? It is drawn there. So this should work. Maybe I've got a, let's do this. Let's do a refresh over in, hold on. Let's do a refresh. Let's actually start running again here because we're debugging. Let's come over here, do a refresh here, and see if there's anything in the console that we need to worry about here. Okay, that looks like allsparks.draw. There's not an draw function. Hold on. Okay, that could also be why we're not seeing anything. Allsparks is a sprite collection. I thought for sure sprite collection had a draw function in it. That would only make sense for it to have that. It does.
Yeah.
So what is wrong with allsparks here? Allsparks. I have no idea.
No, it does seem awfully strange. We've got the declaration, we've got initialization to sprite collection, we've got adding several items to it. Sprite collection, you've just proved, has a draw.
What's going on here? Oh wait, I know what it is. It's totally an awesome problem. Guess who forgot to call load all sparks?
Oh well.
That was me.
That's a very common problem for a lot of people. Ultimately, it's like you write all this amazing code and then either just don't return the result or don't call the method. It's I think we've all been bitten by that one many times.
First time for me, Rory. Never made that mistake ever in my life.
Well, there you go.
Never.
Now you get to join the rest of us.
I was so flabbergasted by the possibility that I made that mistake. I was stunned and I was paralyzed. And I make that mistake all the time, Rory. It's time for therapy with Mark and Rory.
True confessions.
All right, yeah, true confessions. All right, let's try refresh here now and see if we're getting any better. At least let's take a look at the inspect here and see what our console is. Still got problems. It's not finding. Whoa! It's trying to find a huge number of sparks. Looks like I'm using the wrong. Hold on, I got another problem here. Let's go to load all sparks. Frame count. That's my problem. I copied some code and I didn't change that to frame count right there. And it's being passed in. There's what I need. Let's try that again. Let's refresh this and let's come over and refresh this as well. Let's try one more time. Make sure I've really got a refresh on here. I want to see it. There we go. Okay, and I hit it again, so I guess it's refreshing. So I stacked that up. Okay, so what do we got now?
I was going to say a lot less errors, but suddenly.
Okay, that's all right. I know how to fix this. It's a padded piece I've got to pass into it. I thought that was the padded pad file index. I am saying true to pad file index. That's going to add zeros to it. What's saying is it's saying it can't find spark 1, but it should be looking for spark 01.
What's with the left there with the %202 in it? A little bit lower down, maybe 5 lines?
That's going to be a space. %20 is the space, left space 2. So that corresponds.
So it's a legit path then.
That's legit. It's corresponding to my left 2 and my right 2 paths here.
Okay, yeah.
That's okay. The problem is it's looking, I don't understand what pad file index isn't working here. I'm sending in true here. Let's just look at that for a second, make sure that everything's what I'm expecting it to be. Out over here, pad file index it's defaults to false. I'm setting it to true. I'm going into part with the value of true. And there it is right there again. And while pad file index and index string is less than the number of digits,
Where does the number of digits come from?
The number of digits. Oh, I know what it is. I know what it is. That's what it is. Okay. So some of these started with more than 10 digits. And then I trimmed a few out, and then they dropped down. So these are going to be working. This one is not. This one, to solve this problem.
Oh, you've pre-padded in some cases.
Well, no, this has got only...
Well, the images feel like they are.
No, it's because this has fewer than 10 digits, so it doesn't need to pad with any zeros. That's the problem. See what's happening?
Okay.
If I've got more than 10, then it pads with a 0. And so it's got the same number of digits. And I did this because when I use the Adobe tools to create these, like Adobe Premiere, for example, create these, when I create the PNGs, I can do that very quickly and easily from a video, essentially. Cropping, and it's essentially like a custom video to PNGs. So it's a great tool to use. I had a few frames that I didn't want, and so it generated over 10 of these, and or exactly 10 or something like that, and that's why I had an extra 0 in these. So let's just keep going through here. Not my favorite part of the show right now.
Well, I mean, to be honest, everything is good because, I mean, this is exactly the kind of problem that we hit, that others might hit. Okay, so this is real, people, you know, with all warts and all. This is how coding goes sometimes, and at least we found the problem now. We're going to go back, and in this particular case, we're not correcting the code so much as the assets in order to match the pattern that the code is expecting.
Yeah. All right. I'm feeling almost done. The reason I said not my favorite is because I'm like, I like to do fun stuff, and
understandable.
This is not my fun stuff. But at least you get to also see all of the frames of the images coming in here, and so this should totally fix that problem. That's one more to go, I think. Here we go. It potentially, I think, is going to be cool when I get all this together. All right, so that's that. Let's try one more time. So we're going to come over, refresh one more time. And
significantly better.
I think we're good. Yeah, it looks like we're good. Okay, so there's that part there, and you can see right
crosshairs.
The crosshairs. Well, actually, there's two crosshairs on the screen, or you'll be able to see, I think, in a second. There's the crosshairs on the window that I've got up right here, that one, and then there is the other one right around here on the stream.
There we go.
So let's go ahead, and I'm going to get this out of the way, get that out of the way. Let's update the stream as well, and with the latest code. And let's try one more time, a test with Sparks, and see if this time we get to see something drawn. Just waiting for the final load, and here comes the command in the chat room. Oh, cool. So, did you see that, Rory, or no? You may not have seen that.
I'm still waiting for the stream, but oh no, hang on. Yes, there was a spark down around where your name is in the stream.
Yeah, it was a quick flash, and I think that I was like, oh, okay, it's not bad. I think I want to just slow it down a bit, so I'm just going to change my frame interval to like 20 milliseconds on that. The other thing that I want to do is, you'll notice, in fact, let's actually change it to 40. Really slow it down so it's easier to see on the stream. So it's not so fast, and we'll speed it up later once we get this done. Fixed here. Let's refresh with those changes on the stream. We'll get that command out there ready to send that out again to test the sparks. And meanwhile, I'll type on. No, that's all right. I won't do that. All right, here we go. We're loading up the overlay, and it's loaded. Here, watch. Get your eyes right around here. In fact, it's gonna. You're actually gonna see it shoot out down around my left shoulder. So hold on a second. Can I get the mouse? It's hard for me to really point above. I don't have a pointer above. That's something I think I'm gonna have to build, Rory. An overlay, a way to point on the overlay, a command for the overlay to draw a mouse where my mouse is, so I can point to things with like a big. Okay. I need a shortcut command over here that if I'm like holding down, some keys or something like that, or caps lock. That's what I got to do. If caps lock is down, overlay is going to draw wherever my mouse is a bigger mouse on top. So that way, because right now what happens is if I move my mouse, as you can see over here, my mouse is now, if you're looking at the stream, my mouse is over the Solution Explorer. And as soon as I move it down, I fall behind the chat window here, or I fall behind the coins. Or if I move over here into the, you'll notice I'm right on the edge of the editor. When I move to the editor, it turns into an I-beam cursor, and it's pretty much invisible or very hard for me to see. Right? And so what I want to do is I want to be able to point on top of, and also if I move over myself with the mouse, I can't, I'm on the top layer above that. So so what I'm looking for, since the overlay's on the top, I'm looking for a way to point. And so that's kind of a cool thing that we may build in the future. All right.
Yeah.
So anyway, with your eyes close to here, I did find a trick that if I select and put the mouse over it, I can make it easier to see. So you want to look close over in, hold on a second.
So Mark's left side as far as the stream is concerned when you're viewing it.
Here. You want to look right over there on the stream.
Okay.
There we go. So type that in. That was almost painful getting to that. And watch, here we go. Here comes the sparks. Okay? So we see that. Let's do it again. There it is. So
there we go.
So
it's almost, for the stream's perspective, that came out of the capital M that is your name.
Right, exactly. So it's kind of cool. Actually, I'm okay with this slowed down 40 millisecond frame rate. It's not bad. With sound effects, it'll look cool. With seeing the drone bump into the wall, it'll look cool. But the problem is that the center of the origin of the sparks is down right about here. And I'm telling it I want it to be up there, right there at the at the crosshairs. And so Rory isn't seeing what I'm pointing to yet. He's got to watch the.
I've got the idea there. So basically, if you can imagine a rectangle, which is after what we're plotting on the screen, and there's your sparks. The upper left-hand corner of that rectangle is your origin, but the visual origin of the sparks is more the lower left in this particular case.
That's right. And so what we want to do is we want to fix that. And one of the things I did in anticipation of fixing that is I opened up each one of these up into an image editor, and then I went down. I just hovered the mouse over that location. And if you look in the bottom right, if you put your eyes right over here in this image editing tool where I'm moving the caret, when I hover over there, you'll see,
coordinates.
11.
So X is 11 across and what, 354 down?
That's right. And so what I did is I took that data in my load all sparks function, and I added it over here.
Very nice. So you've got a built-in origin of the sparks with respect to any given sprite.
Right, exactly. And so, in fact, I like that, what you called that. So I'm going to call this origin X instead of start X. And origin Y. Okay. I'm passing them in, but I'm not doing anything with them. What I think I want to do is something like this. Hold on, I want to copy this. I want origin X is equal to origin X is what I think I want to do. And origin Y is equal to origin Y, like that. And then I want to declare these, and let's declare both of these. Oops, shit, no, not that. And oops, Family Show didn't say what I just said. Yeah, we talked about this before, the ordering thing. They're doing alphabetical order here, and they're creating they're adding change spelling to origin X as the first one that pops up, but they should really make it declare property origin Y.
We'd really prefer sort of a most recently used above, especially if it's been very recently used and you're in a sequence going, I'd have to do this and do it again and do it again. And hang on, suddenly the sequence isn't what it was. It's unexpected. You have to spend extra cognitive load going, well, what happened?
Yeah.
And now you've distracted yourself from your main task.
This is an opportunity for the Visual Studio team to improve this. So so definitely take a look at that. So let's so instead of, because what did I do? I hit the key. Let me undo it a second. Let me undo and go back. Oh wait, let's go to here. Wait, there's the change I made. So here's where I started. I hit Control Dot here. Oh, it's not undoing across the other side. Okay, well, I guess I'll have to delete that and come back to demonstrate it. Yeah, I came in here. I hit Control Dot. and I hit enter because it was right there, the first one, and
It
now,
says declare property, and that's what you want.
right.
That's brilliant.
And now I come down here, and what do I want to do? I want to hit Control Dot Enter. And the problem is
Yeah.
it doesn't give me a fast path to repeat the last piece I did. So it really needs to change the order there, or alternatively, don't change the order, but select this one for me if you
Yeah.
want. I'm okay with either of those, but just make it easy for me to do both of those. So now I've got origin X and origin Y inside of here. And now that I've done that, I need to figure out how that's going to impact things. And I'm looking for a draw function in here. There it is, right there. And I'm calling draw on sprite. We were working on this just the other day, but sprite knows where its position is, right?
Yeah.
So I think we need an offset that we
Yeah,
need to
I mean,
pass in here.
Are we essentially saying that? Okay, so let's imagine we've got a spark that emanates from the upper left. So before we encountered this problem, that meant that the origin is exactly the same as the upper left. What you've given is a set of extra information for this sprite to know that there is a difference between those two factors now. So I'm assuming that when we say, I want to draw this at, I don't know, 50 pixels across, 50 pixels down, it gives you the convenience of knowing that the sprite's origin will emanate from that point.
Yes.
I.e. that it will spark out. So we're just doing the right kind of addition subtraction of that origin versus our plotting point, right?
Yeah. We are. What if, let's do this instead. Let's create that awesome add function that I wanted to do, that I wanted to create. What do I want to pass in here? I want to pass in this. Just like that. I want it to be that simple. Since in most cases we're creating a sprite proxy. So let's declare the method, the function. Let's get inside that function. What did I have here? I want to say so this dot sprites dot push new sprite, and let's change this to X, and this to Y. Oops. Like that. And let's do, I think I'm going to just find a faster way to solve this problem, Rory, is what I'm suggesting is
Sure.
that, and it doesn't, this wouldn't work across the board for all the different sprite types, but what we can do is we can do X plus, or X rather minus this dot, what do we call it? Origin
X.
Yeah. And Y minus origin Y. And it doesn't quite work for everything, but this 0 is the starting frame piece. Actually, let's do this.
You'll push that up into the params as well, potentially.
Yeah. I'm going to make it a one with starting frame index.
Yep.
Like that, and I'm going to set it equal to 0. And make it, well, I guess it's already optional because I've given it a default value.
Yeah.
And I think that's not bad for now, is what I think it is. So not bad for now. So there's my add function. So now, if I do that, we should see the sparks. Let's do this. This sparks.
Well,
2.
essentially,
Go
if you
ahead.
don't, if nothing particular changes, then we should see the actual spark leap up by approximately 300 pixels and left by about 11. Right, so it emanates instead from, I'm going to say roughly the height of your head on the screen, but maybe a body width to the left. Actually, probably no. It's approximately where it was, isn't it? So it's still roughly above the M, but considerably higher.
It should emanate right out of those crosshairs because I'm passing in the crosshair.
Of course, sorry,
Parts
forgot
in there.
about the crosshair being there. So yeah,
I'm like,
that'd be really good.
as you're describing that, I'm like, Rory, I'm way more optimistic that this is going to work. That this is going to be better than what we're saying here. All right, so here, let's do this. Let's just grab this. I wonder what can I? Nope. Let's try this. I was hoping it would auto increment, but I think we're not going to get the auto increment in here. I think it's going to be faster to. Let's just get a bunch of these down here. All right, and now come in left 2 sparks. And there's that. And right 1 sparks. Right 2 sparks.
But the great part being about any of this is that as we execute any variation of sparks, it will all come out from the same location. So the sparks that origins or has its origin in the lower left will appear to go up and to the right, but the one that has its origin in the upper right will appear to go down and to the left, and they'll all come out of the cross in different directions.
Yeah, that's what we're absolutely expecting to happen right now. That would be so cool if that worked. Let's try it out. All right, here we go. Here comes the, looks like Rory's already trying it. It's got to be test space sparks.
Oh, so I'm
1.
not quite right. Okay, yes, good point.
There's 1. That one worked. There's 2. That one worked. There's, whoops, looks like 7 didn't work. Wait, hold on a second. 3 didn't work. 4 didn't work. 5 didn't work. Wow. Maybe did I fail to get the right data in here?
What happened?
I don't know what happened. That's like really, really weird. Let's go back to 1 again. 1's totally working. Why? 1, 2. So 1 and 2 are good. Let's take a look at this. What's going on? That doesn't make sense to me at all. Left. Origin X and Y. Did I really blow it on all these numbers? I don't think so. I felt like I was pretty careful entering these in. Let's double check it. So left 1 sparks are from the left folder. Let's look at that. Here's the left folder. Let's
Which is the upper right-hand corner. So that's going to have a high X and a low Y.
What I've got here is 351 and 40 about. And then the code, I've got 355. Yeah, it's about right. So the left 1 sparks.
So left 1 sparks is maybe...
Let's see which number it is. That's 3. So left 1 sparks should...
Oh, you've got a cross Y, cross X. You're inverting on most of those.
Oh, Jesus. I know why. Because I used a duplicate line to get here.
Yeah.
That's what's wrong. Okay. Good job spotting that, Rory.
No problem.
And then I used copy to just copy it all the way down. All right, so there we go. Let's try
I
that.
think confidence is high again, though.
Confidence has gone back up here.
Yeah.
All right, so we are reloading. Let's get this out of the way.
Disclaimer! Mark doesn't know what he's doing!
Nice job. I love that Will tried once and Mr. AnnouncerBot was what? And then he's like, I'm going to do it again. And Mr. AnnouncerBot was fine. And I think it was because...
I figured it out now,
yeah.
he says.
It's awesome. Okay. All right. So here we go. Let's do test sparks 3. Well, there we go. It looks like you had already done that. And 4, 5. Excellent. 6. And 7.
Just all firing at it. That's really good.
Yeah, it's fun. Do we have an 8 or not? Yeah, we do have an 8. There's the 8.
Maybe.
Okay, cool. So, excellent. So sparks are working. We've got all those resources loaded. Just to make sure we're still flying, still able to plant seeds, still able to drop the drones, move those around, drop the paint. Whoops. It looks like we're good there. And yeah, I think it's good.
I have to say, I got a really good feeling about having that origin stuff in there, because now we can actually, rather than have each individual thing try to calculate where it should be, we can sort of position the origin inside the sprite.
Yeah.
for example.
Yeah.
That'd be allow us to migrate some stuff, make things just a little easier to read in some
Yeah,
places.
I'm pretty happy with it. Okay, so next, to get the walls up. So I've got a test command to bring up the wall. Let's see if that works. There it is. So what I want to do is I want to throw it up on screen is what I want to do. And so I want to throw it, and then I want to have it move once it hits. And I think I think the code is not hard for this. Let me dock for a second here. By the way, Rory, you may have noticed in the stream when we docked, this is another thing we did, I think, while you weren't here. All the drones explode.
That's
like that.
kind of nice, isn't it?
Yeah, we also want to
So-
make it... I'm sorry, go ahead.
I was just wondering if we've got an explosion going, so we probably don't need fireworks and sparks going off, but I can imagine that it's the sort of thing you could throw in occasionally. But yeah, no, it's really good.
No one's going to stop me, Rory, from putting sparks and explosions in this all over the place. We're going to do that. Okay, so the other thing I want to do when we dock is I want to clean up all the walls as well. When the dock command is initiated by me. So we'll need something to clean up the walls. We'll need to hold on to walls. We're also going to need to create a descendant of the sprite proxy that's going to be a wall so that we can check to see we check for collisions. So there's still like a fair amount of work we have to do, even though it looks kind of really cool. But the first thing I want to do is I want to get the throw into position. So let's work on that first. So to do that, here I'll get rid of that for a second. We'll switch over to this view. Actually, I'm going to go right back over here. Just so that if you want in the chat room to bring stuff up or do play with things, you can do that. But let's see. So I want to get the wall up. We're pushing this in right here in the wall. Let's go look at the wall class. And we have a update position is what we have right here.
Yeah.
And when we start, we have an X and Y. Here's where we are wanting to be. What are we doing with the X and Y? Nothing yet, it looks like. So the X and Y is where the target is. I think what we're going to need to do, and this is where, hold on. We're creating the sprite proxies. This is the X and Y positions of the end caps here. And we have two different kinds here. We've got a horizontal one and a vertical one, which is down here. And this just basically says here's where they're going to be on screen to be centered around those crosshairs. So you see the crosshairs right there to my left, right there. I can just about touch it. That crosshair is, that's what these are centered on. What I want to do instead is I want to have that be a destination point that we calculate, and instead create these end caps off screen below at the bottom, down below and off to the side. So the end caps are going to have a starting point and an ending point. And then I want to throw the end cap up so its apogee passes right through that end point. And then when it gets to the end point, I want to stop it, is what I want to do. Okay?
Yeah.
So that's...
So you're going to kind of have an off-screen cannon that fires it on a slight arc, arrives at that point, and at that point, it stops and expands as per original design.
Right. Now, we have a slight problem in that the amount of time it takes to reach a point based on gravity and the throw is different based on the height, right? Because we need it to hit an apogee, it's not just passing through it, we want it to be at its apogee. Right?
Sure, just as it's about to start falling back the other way.
Yeah, so what we need to do is we need to essentially calculate how much time until we hit that spot is one of the things we need to do. So we need to do some math is what we need to do. So let's at the very least come in here and make some of these changes here. We are going to...
Sounds like we're going to enhance our physics engine.
I don't know if we need to actually. We'll find out really soon. Is what I think. In fact, I'm kind of like, I feel like my brain is arguing with itself right now as to whether to promise you that we can do this before 11 o'clock or my time, which is 20 minutes from now. I think we can do this in the last 20 minutes or less.
Okay.
Will Bennett says math. Ugh. Will Bennett says maybe a comment saying vertical. You know what? I like that. How about this? I do that often. I totally agree. Like this, vertical. like that. Yeah, I could have done this here, but there are only 2 choices. So I was like, you know, so let's just do that. We'll do that. And I'm happy. Okay. So now what I want to do, so I've got a cap left property and a cap top. I just want to look at these. And now what I want to do is I think I want to change cap left and cap top to I'm thinking about renaming this to like a kind of the wall center. Let's do that. So we're going to say wall center. Well, it's already the wall class. So we're just going to call it center X and center Y, like that. And so now I'm going to come in here and I'm going to say center X is equal to cap left. And center Y, is that really true though? Because this is really the upper left of the cap. This is not really the center, is I think the problem. And good,
well,
Roy,
the
what do you want to
center
say?
Y is presumably, we're talking about the lightsaber sort of piece of this, and that's going to cut straight through the crosshair, isn't it? So actually, is that not correct?
Hold on. Oh wait. Yeah, no, it's definitely not cap left, and it's not Y either, is the problem. I can get a center X and Y. Maybe that's what I need to do. Let's get a center. The problem is this, is when I'm drawing the ball, right? The upper left is not the center point, right? It's obviously not, right? It's up here. When I've basically at this point calculated where the center, where the upper left, where I need to draw the ball so that the ball is over the crosshairs. That's what so the center X and Y are poorly named, I think.
That's because you didn't have any kind of origin facility before.
No, I don't think it is. This is unrelated to origin. Origin was related to the sparks, and this is the wall. The wall is we had just lined everything up so it all worked. So unfortunately, it's not as simple as that. So what I'm going to do though is I'm going to say ball. I'm just going to call this ball top, like this.
Okay.
Wait. Hold on. I'm starting to mess things up here. I'm going to go back with I'm going to go with cap left and cap top. Cap. Let's do this. Let's do this. Let's do this. Let's rename this to, wait, I have to say this dot cap left. And then we're going to come down is equal to that. And then we're going to say this dot cap top is equal to Y. That is feeling better to me. End cap is equal to, we need to still figure out where we're going to start from. So we're going to take this code out of here and put it down here. Figure out start. Starting point for cap. So we need to do that. So, and I want to come in, take this and put this here. And I want to rename this. I want to put the word final, I think, in front of these. Final cap top. And final cap left, at least in terms of the center point before it spreads out. And so we'll also be able to collapse back on that spot as well.
You've got a couple of cap top and cap left references down below that are not currently this dot final.
Yeah, I need to fix this anyway. This is going to be replaced
Okay.
with something else. So we've got these two here. Then we're going to come down here and we're going to say this piece right here, we're going to say this is equal, cap top is equal to this, and final cap left is equal to this, just X, okay?
Okay.
We also need the indexes for these two. Hold on, we're going to need to, we need 2 numbers. Cap 1 index and cap 2 index, like that. And over here, we're going to say cap 1 index. In this part, we're going to say cap 1 index equals 1. 0, I mean, sorry. Actually, we can just do this. We're going to do this. Cap index is 0. And over here, it's equal to 2. And then we're going to use it here, cap index and cap index plus 1.
Yeah, so this is the starting frame index apparently in the sequence.
Well, yes.
So for the was it left and right was the first one, so that's 0 and 1, and therefore the start is 0. And then when you're going vertically, that's 2 and 3, and therefore the first one is 2.
Yeah, this is what we're talking about right here. So we have these different indexes here. So we're going to go, if I say starting index is 0, that means we're going to be these 2 we're going to use. And if we say it's 2, it's going to be these 2. Yeah. Interesting. You know what I could do is I can come in here, open with Google Chrome like this, open that image up, right click it, copy that image, and for clarity, come in here and pop it in at the end like this.
Very nice.
Like that. Let's just shrink it down a little bit so it kind of doesn't take up so much on the line. So there's, we've got end cap is equal to 2 and end cap is equal to 0. We can do the same kind of thing here so that it's super, super clear. Come over here, open in Chrome. It's on the other side of the page. I'm just going to copy that instead of dragging it over because I'm sure you can imagine what a copy looks like, and then paste it in here and shrink it down as well. All right. And so there we go. So now we've specified our cap index. We've kind of very clearly said what those are for, and we don't need this anymore. Next, we need to find out where we're starting from. So we have our final position. And I think what we need to do is something like this. We're going to, I think, make at least one change to our physics engine. We need to find our distance to the ground from that point. So we're going to say ln distance to ground is equal to the y position. I think this dot final cap top. And it's going to be actually our height, which is 1080, which I don't think I have a constant for anywhere yet. Should I declare one or not is my question. I'm going to guess I'm not going to do it for now. So distance to ground in pixels. This is in pixels.
Mm-hmm.
Then we want, or maybe we should do this in meters. And now what we want to do is call physics dot pixels to meters. We want the opposite of this. So we're going to at least need to do that. Create pixels to meters. Oops. And we need to declare that. And so let's declare that. Jump into it. And take it in here. So we want to, this is going to be pixels.
It's just a basic division, I guess.
It is, but I want to make sure I don't mess it up. I'm looking at it very clearly, you know, so I'm very clearly, I want to have clarity before I write it. So it's pixels,
number of pixels, which
divided by pixels per meter is what I get. You get the same thing, Rory?
I do indeed, yes.
Okay. All right. So that's going to be pixels to pixels to meters. So that's my distance to the ground. The next thing I have to find out is I have to find out how long it's going to take to fall, because the falling time has got to equal the throwing up time till it hits the apogee. That's got to be the case. I need that falling time so that I can know when I've reached my spot, or when I'm close to it at least. So what I'm going to do is I'm going to throw it, and when I get really close to that time, when that time comes up, we're updating all the time, I'm going to snap it into position, is what I'm going to do. So that's my distance to the ground right there. And so now we've got to calculate falling time. And this we may need. Yeah, we don't have this. So we need to calculate the time it takes to fall to the ground. So let's do this. Physics, time to fall to ground.
I love that first hit. The splat calculator. That is exactly what that sounds like. That should be doing.
Yeah, what
Not
I'm looking
sure
is
that
the
we've got an
formula.
equation, really. Yeah.
Here we go. Getting close. I'm looking for something just standing out. I'm going to
Well,
skip.
there's a second item in that, which was it the square root of? I forget. It's the second bullet pointed item.
Time to splat. Square root.
Square root 2 height over 9.8. So gravity, G.
Got it. Fine. We'll take that. That's what we want.
Possibly.
I'm gonna
Sounds
believe
good.
it's true. Let's see here. We're gonna call this. This is a static function. Do I have an st? Nope, I don't. Static. And we're gonna call this time to drop time is what I'm gonna go. Get drop time. Yeah, get
Miller!
drop time. Hold on. Somebody's talking to me in the chat room.
Yeah, we've got a new person in the chat room there, ZDoctor, who's saying hi and was just checking whether or not we read the chat, which we do. But absolutely, as Will Bennett says, if you want to get our attention, splat mark or bang mark.
Yeah. Sometimes, yeah. So, Z Doctor, thanks so much for asking that question and for saying hello. Glad to have you here. We normally do, but sometimes Rory and I are so focused in what we're doing. So we added the ability for folks in the chat room to type in the bang symbol and mark like that, and it'll get my attention, and I'll come right over there to the chat room and talk to you. So go ahead and feel free to do that anytime you've said something and I haven't seen that. All right, so we're going to call get drop time, and we're going to pass in the height here in meters, and meters like that. I guess I'm going to do that to make it very explicit. And then we're going to say return math dot square root. And by the way, did I miss anything from Z Doctor at all?
A little discussion whether or not he has a TARDIS.
Okay, that's it. All right, I just want to make sure I was like, okay, let's make sure we're good in there. All right. And this is going to be times acceleration. So we'll actually pass that in as a parameter. Second parameter, and we'll do that right here. Whoops, there it is right there. And then I think we're good there. Then we can come back over here to wall, and I just noticed something. Check out wall, the icon here. I think that means my code's broken. There are warnings in it. That's kind of cool.
That's novel, eh?
What'd you say?
That's novel.
Yeah,
Not
no, I
seen
love
that
it.
before.
I love it. I'm like, oh wait, I got a problem immediately. Nice. I think that's awesome. I think that's what it is, and I think I like it a lot. So there's our distance to ground. We're going to call physics.getDropTime, and we're going to pass in our height in meters. Like that. And we're going to pass in our acceleration, which is...
That's a function of which planet we're around at the moment, right?
Yeah, I think it's in Gravity Games dot active planet. Let's double check and see if we see that anywhere else. Dot gravity is what it is.
Okay.
Okay, so let's go back over here to active planet dot, and yeah, this is pretty cool. For all of these planets, we have all of this data that's in there. So we could at some point in time put that data on the screen as planets change. All right, so we want to choose .gravity. Okay, and all right, we've done that. So there's our drop time. So we're going to say we need this to be something along the lines of this dot throw time, air time equals this. So that's going to calculate our air time, right?
Yeah.
Hold on. Oh, well, let's declare it, of course, because I just typed it in. So we've now declared airtime. The next thing we need to do is, now that we know the amount of time, we need to figure out our velocity to get there. But we've already got a function to do that. It's physics dot get final velocity. And it's going to take a time, which we've got. It's this dot airtime. It's going to take an initial velocity with 0. That means the reverse of this, we want it to have 0 velocity when it reaches that point. And oh, by the way, Z Doctor's asking what we should give Z Doctor a demo. Let's do that. If you want to,
It's a good question. So Z Doctor's asking the question. So what kind of game are we making? Well, we started off making just a pure JavaScript game, but we quickly got diverted into games for the chat room. Essentially, there's controls that you can enter commands into the chat room, and that you can launch our own little icon up there. The CodeRushed Ed becomes a kind of a rocket, which you can drop drones from. The drone is controlled by the individual who caused it to drop. You can navigate across the screen with it, and you can drop paint. You can catch meteors that are effectively thrown out by the main rocket ship. And we're building a kind of an ecosystem, an environment where you can, as chat room members, just have a bit more fun, a bit more interactivity, a bit more control over what's going on. So very similar to the ability to call out to Mark with commands, the ability to command these various elements. Now, one of the most recent things that we've added to this is, so we've got our drones that are flying around and being able to move around and perhaps catch, and we say maybe we'll invent some kind of a game to play with the meteors because we can throw those now. And then the idea will be that we're maybe going to put some barriers up. So we've started creating these walls, and the walls are kind of like the electro kind of lightsabery kind of things that you might have found in some old arcade video games, so like Space Invaders, or maybe slightly more modern versions of those available on PC. So what happens is a little ball is going to be launched onto the screen, and it'll open, as you can see just there, marks caused to happen, a couple of walls overlapping. And the idea is that the drones will be unable to fly through the solid walls, the sort of pinky purple variation there going on, but on the other hand will be able to fly through, or maybe the ball will be able to go through the slightly more intermittent electric fence of the blue version. I think that sort of covers our goals for the moment. The little bit that we're working on just at the moment is the ability to throw this almost Pokeball style ball onto the screen and have it just at the very apex of its, as it's about to start falling back down, to then suspend itself in that one location and then open as we saw there. So it's more of a stylistic effect that we're adding at the moment.
Sorry, no sound there. Better? I think it's better.
Dude,
Got it.
check out the chat room.
Yeah, there you go. Will Bennett demonstrating. Sorry. So I'll just repeat what I was saying. You can throw stuff here as well. So let me just go up a little bit. Go right by about 0.3 seconds. And then let's drop again. And then there I've caught it. And then we're going to toss it. And we're going to toss it. Let's look. My last toss was, what was it? 5,8. So I'm going to toss 5. Let's try 5,8 again and see where it goes to. It's going to go to Z Doctor. So I'm going to do, let's do drop another meteor, and we'll do another toss, and we'll say this time we'll say 6,8.
So Z Doctor has commented again. So we're streaming creation of stream games. That is a very nice, succinct way of basically summarizing everything we said. Yes, that is exactly what we're doing. And all of this stuff is in a repository that you can get yourself, apart from the actual graphical assets, which have some slightly more complicated
licensing restrictions. Yeah.
Sadly, that's the case. But all of the code is available on GitHub, github.com/Millermark, and this is the Mr. Announcer Bot repository. So if you want to go and look at all the code, it's all sat there waiting. We post it all at the end of each episode. If there's any changes in between episodes, they'll get posted as well. We've got tags for pretty much every point that you want, and you can follow it right from the start, or just get the latest code and continue. It's all up there for you to see.
Yeah. So anyway, that's kind of what we're building. All right. So let's go back up into the code that we're working on. Let's get back over there.
Sure.
So that's kind of a summary of it. Let's go. Let me actually clear everything out. So we've got everything off the screen for a second. Yeah, that's what we're doing. And we're also learning JavaScript and TypeScript, and we're doing that all along. When Rory and I started 40 episodes ago, we were brand new to this, and we were like, all right, let's work our way through it. And as a result, folks in the chat room have helped out, including including Will Bennett,
Will
who's,
Bennett,
who's
Simon
here right
Gearing, we've
now.
had a few contributions. It's been really useful, actually.
SQL Mr. Magoo, Sakelo, all kinds of folks have been helping us out. So we appreciate that. All right, so now we've got our initial, let's see, we've got our initial velocity y, we now know that. And then our velocity x is, we need to calculate a velocity x and a distance that gets us, from whatever distance we start, gets us there at that point in time. My sense is that I think what I really want to do is let's figure out an initial velocity x, and from that derive, a time. I want a time? No, wait. Let's start with a velocity x. So the velocity x is always going to be the same. It's going to be like, moving about that far. That speed right there. That's what I wanted to move across the screen. So I'm guessing that's about 3 meters per second or -3, depending on which side we're going to be at. But the initial velocity x is that. Now we have to figure out the distance where we're going to start that. We know that y is going to, hold on one second. Here is our height in meters. Let's add to this. Let's do one thing. I want to see I want to see how big this thing is in meters. Let's go to physics. Pixels per meter is 50. So 50 pixels per meter. This is 68 pixels for this ball. That means the ball is about 1 meter high is what it is. So that means that what we need to do is our drop time, our height, we need to add about 2 meters to this. Probably about 1 point, or we could do it this, plus physics.pixels. Oh, let's just do this. Plus end caps. Let's just get it below the screen. Dot sprite height. Like that. So now we are definitely below the screen, or at least enough that in an animation it's not going to be a big deal. Okay, so pixels per meter. So that is our height in meters. So we know now at this point that our starting x dot cap x is going to be equal to 1080. It's going to be basically right below the bottom of the screen. So we know this. We're kind of working through and getting all the pieces we need to know. Oh no, that's not x, that's y. Okay, cap y is there. Okay, so that's cap y. Z-Doc says, I saw Deb Chatter also creating a game for the stream the other day too. Yeah, Zombie Game and Hangman. Yeah, we're kind of pushing things in a different direction in terms of what can you get that's playable in a chat room that's also kind of looks like a more interactive 2D platformer kind of game.
Slightly more real-time-ish sort of thing. So
well,
we could do noughts and crosses and what have you, but there wouldn't be a lot of movement going on, I guess, with that kind of thing.
Yeah, the key is, I think one of the things that's important when you're creating a chat room game like this for live streaming is that that lag is not an impact on playability, right? Should not have any impact on it. So and so that's what we're trying to do here as well. And there are a couple different game kind of genres that I think you can do. One is just sandbox play, where you like drop a seed out, and it plants, or you throw paint on the screen, right? And it's just kind of there in a way that reflects, where you want to, just the artistic play. There are things like collecting things, like collecting coins is something you can see we're getting setting up for. There, by the way, there you can see over there, Will Bennett's just planted a seed there as an example. So that's kind of where we're looking to do on this. So okay, so we've got our cap y, we know that. Our cap x, we've got to calculate it, and I'm going to need another formula here, and this is going to be physics dot. I think we need is get displacement. Can we do that? I think we can. The time we know. This is perfect. We don't need to add anything. The time we know. The initial velocity will be 0. I think, no, the initial velocity is here, that, right there, and
Yep.
our acceleration is 0. So this is going to tell us how far it would go if we set it at that velocity. So now we know cap x is equal to our final cap left minus that. This is going to be off to the left of it, and then it's going to come up like this. That's our cap x, and our cap y is this. And so now we know what goes here.
Z-Doctor's just asked, so what would happen if 10,000 plus people joined and tried to play your game? I'm going to say bring them on. If only because it would be interesting to find out.
So yeah, basically this question is scaling. Right now, my anticipation is that the 10,000 people won't join all at once. I think if they did, I would have to switch to this view right here, which prevents it, or I would have to manually switch off the overlay if there was too much load. However, in what I'm anticipating is that there's a growth to, yeah, Will Bennett says, plus Mark just got a new machine. This machine can handle 10,000. Come on. What was I going to say?
It is an interesting point that it is your machine that is essentially handling this, because your machine is using OBS, which is then reaching out to the web server, which is then downloading this JavaScript and running it in response to commands that it then retrieves via Signal R from the chat room.
Yeah, it's designed to be able to, right now, being able to draw 10,000 of these things on screen would probably slow down the effective frame rate, and you'd see like a bunch of chunk on things.
It might be difficult to make out the code.
Yes, absolutely. But ultimately, what I expect to happen is that growth will be slow to reach that 10,000. Ultimately, I could die before that happens, and along the path, as we see stresses occur, then we might come up with means to reduce the stress, either by improving the efficiency of the code or by limiting the number of players. Maybe, for example, it can be something that's earned to be able to fly a drone, that sort of thing. So there are lots of things that we can do to respond and react to 10,000 plus viewers. But, you know, we're coding, folks. We're not, playing, we're not Dr. Disrespect, playing crazy games and being super cool. We're nerds, and as a result,
Dance battle!
Oh, it is time for a dance battle, though. That's true. We do the dance battle every time, and bum, 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 bum. All right, okay, enough of that. Let's get back to some coding. By the way, it's really bad when your kids can dance way better than you, like way better, and your regular conversations with them are, hey, can you throw in a few mistakes or some clunkiness to make me look better? And they just can't do it. All right, so let's see. We've got our starting point. We've got our initial velocity x and our initial velocity y. I think that we can come in here, and I think we can say, there's something in here, change velocity, like that. And I think what's going to happen is it's maybe not going to work. And because this will only work if, initial velocity x and initial velocity y. I think this is only going to work if n caps, the sprites around it is said to be moving. And I'm not sure it is. I think it's not. Let's go back to main and take a look at that. Because when we created our n caps,
I think you're right, because they've been hovering there and therefore not subject to gravity as yet.
Yeah. So let's look at our n caps. We don't have a call that says it's moving, which means we're going to have to move these ourselves, is what we're going to have to do. So what's going on here? Expected 3 arguments.
Need a now.
And a now. Do I get a now coming in here or not? I do not. So let's create a new now. That, and there's my now right there, and let's do the same for NCAP 2, like that. And there's the switch over there, because it saw, this is the one thing I want to fix about duplicate line, smart duplicate line. it changed the X's to Y because it saw us changing before, but I really want it to know, hey, wait, that's X and Y, and these are parameters. It's actually swapping the parameter order. We're not going to
Yeah.
do that. Like on a...
I think it's quite logical in some respects, because if you've got a line which only has X on it and you try
Yes.
to duplicate that, then it's logical. But if you've got both already, then
Don't
you maybe
switch.
want to maintain that consistency.
Absolutely. Can you take a can you take a screenshot or mark this, Rory?
Yep.
I want to
No
put...
problem.
I want to do a... where's our chat room icon? There it is right there. I'm going to send just that code to you right there. And then you can go send an email to me and the devs, and we'll take a look at that and try to fix that so it's smarter. Definitely want
On
that.
it, boss.
On it, boss. All right, so so I've got our change velocity. So we've now got the velocities right there. But now update position. I think what we want to do here is we want to see seconds pass, and we want to say, let's see, do we have our final time? Where did we get the drop time, the air time, the drop time? So that's our air time. So what we want to do is this. We want to say if seconds pass is less than this dot air time, if that's the case. Oh, Will Bennett's asking, isn't it time for Rory to go in to go? Yeah, Rory, what do we
Is
got?
that what he meant?
Yeah, giveaway CodeRushed.
He was asking if I was going to get into trouble. I was like, what did I say?
Yeah, no. So, so if seconds pass is less than air time, we're still coming up. And what I think we want to do here is called this dot end cap. Do I have an update position here? Would that be so cool? And I do. Hot.
Yeah.
That's hot. Okay, and then come down here and same thing here. So now if I call update position on these, now let's just double check, make sure that code's all going to work. Yes, yes, yes. So now gravity is going to work on these things if we're in this zone. Okay. And then I want to say else down here, like this. Whoops. Else and that. And now here I want to ask the question. I want to say if this dot still flying, then I want to do something like, actually, let's do this. Let's do that and that. So if we're still flying, then we want to set still flying to false. I'm going to fix this in a second. I'm going to declare it in a second, and we're going to set still flying to true up here, like that. And let's declare it. Okay, so we've declared that. So if we're still flying, then we're going to set still flying to false, and we now need to snap it into position. And our position is, where was it? We had a final cap left and top, right there. That's what we want to do.
Yep.
And so now we want to say is end cap dot x, right, is equal to this. I think we also want to say change velocity to 0, 0. So it's no longer, so we make sure it's absolutely not moving anymore. And because we're not calling update, we won't be calling update position on anymore. It shouldn't be falling. It should snap right into position. So we're going to say endcap.change velocity 0, 0.
Now parameter to that too.
Right. And we're going to do the same thing with endcap2, like that. And there's...
We need to assign the... Oh, do we need to assign the Y? I guess so. To the final cap top, isn't it?
Yes, we do. Final cap top, and this is going to be Y right here, like that. Okay? And then this, I think, is just code I copied from up above. So if we're still flying, then we're no longer flying. We're going to change velocity to nothing. We're going to snap ourselves into position. Holy cow, this could all work. Shall we give it a shot, Rory?
Yeah, go on.
Do you think we're done? He's like, yeah,
Hey,
do it.
Could be.
I can't remember if there's anything else I need to do. All right, let's do the reload.
We're already drawing the various parts, so this is all about the manipulation and the direction and stuff like that. So
Yeah.
this should be good.
So we'll see what happens. We'll see. Okay, here we go. We're almost loaded. And
Check your airbags.
check your airbags. I'm so nervous. Go. Nothing. All right. Sometimes sadness happens. Let's see what we got here. That's not where I want to be. I want to be in this one. I want to see if we've got any errors. So let's refresh this. Ah, wall.js. Wouldn't it be nice if that was our problem? Line 29. Yeah, well, wait, that's in the JS. This is in the NCAP sprite height. Let's go take a look for it over here. Here. That's my problem, I think.
Yeah.
Yep. Okay. All right. So let's do that. Let's refresh. Let's refresh here as well. Look for errors. See what else we got. Okay. That no errors that time. Z Doctor's gonna roam now. All right, Z Doctor. Thanks for stopping by. We will see you later. Let's try the wall. Uncaught in physics. Throw pixels. Oh.
You know, I stared at that and I went, "It's fine. It's nothing wrong with that. It's just because the colors they threw me."
That throw keyword needs to be different color, I think. I would
Yeah.
I would argue that. All right, let's try one more time. Z Doctor's now following. Thanks for that follow, Z Doctor. We will see you later. Here we go. Refreshing. Let's refresh over here on the stream as well. Let's just do another test wall. Here it comes. I didn't see a throw.
I didn't see a throw.
Hold on. Oh, wait, I know why. It's in here. It is here. This. If seconds past is less than extend time. What we need to do is say it is less than this dot air time plus extend time. That's what's happening, I think.
Okay.
Okay, so let's try that again. So we'll refresh again. I'm going to do it just test over here. And let's see. Ready to go. Here's the test the wall. Still no.
No.
Wait, did I get it? Did I?
That was going further.
Tell
And
me.
it snapped back.
Oh, I didn't see that. Let me see that. Let's look at that again. Maybe we've got a problem here, a logic problem. Let's wait for the refresh to be finished. It shows it's still loading. I'm looking at the loading spinning dial right up here. Come on. Should be done. Well, let's just try it. I'm just going to send the command through and try it. Yep, no, it definitely thinks it's not loaded yet. We're not at debugging in the background.
No.
All right. Let's come over here. We'll do it on our main one. It's weird it's not loading. It thinks it's loading. Let's do this. Let's stop it. And let's do an empty cache and hard reload. Just try that. Okay. Still loading. All right. In the meantime, the stream one appears to have loaded. Yep, it's loaded. So let's do the test in the stream. Nope. Went further. You're right. Totally went further. So we've got a couple of problems here, I think. I think I didn't look closely enough at the code in the update position here. Yeah, I think I see what's going on here. So I think what we need to do is this. If let's change this. Let's say seconds past, and then we're going to come down here and we're going to say seconds past equals seconds past minus airtime. And then we're going to say if seconds past is less than 0, then return. And let's try that.
Okay.
I'm not even going to double check the logic there. I'm just going to reload it and try it. See what we got over here. This load eventually finished. Let's try one more refresh over here. See if it comes in faster. It's done. So, and how are we doing? With the other ones, looks like it's loading in too pretty reasonably fast. So let's get that. Let's send out the test wall again. So it's like the throw didn't happen. Wow. In cap.
Tarzan Panda!
I think we're going to have to set a breakpoint and go through this, is what I'm thinking we're going to have to do. This changes the calls to update position should work here. I want to step through it is what I want to do. So
Yeah.
I think to step through it, we're going to have to kind of reset this a minute for a bit. Roy, what's your stress level right now with regard to needing to get out?
I can stay for a bit. I'm really curious to see how this goes because
Good.
I'm really loving the effect so far. But obviously that throw is kind of what we've been hankering on for this little while. So I'm really curious to see how we go here.
All right, so give me a second. Let's. I'm going to kill all instances of Chrome. And then we're going to start running this again. So we can now set a breakpoint here. And I think we're going to, I'm going to set a breakpoint here. And I think I want to set a breakpoint here and look at our numbers as we go through this and make sure they all look good.
Yeah.
Too.
It'd be good to actually get an idea of what the airtime actually is and things like that. So hypothetically, this has all been, fairly good logic, I think. But
I think
to get a real feel for those numbers is quite important.
I think we have a small problem, not a big problem, is what I think we have. So, all right, so we're loaded up here. I'm going to now send the test wall command out again, and that should get us to our breakpoint. Let's step through and take a look at what we got. So our final left top is 846. I'm sorry, final cap left is 846. Top is 730. Those are looking good now, like good numbers to me.
So that's our ultimate destination. That's where our XY effectively is. Yep.
Height in meters is 8 meters, so it's about 8 balls up. 1, 2, 3, 4, 5, 6, 7, 8. So it's about that high. That's also looking good. Airtime is what? It's about 1.3 seconds. That's also feels good to me.
Yeah.
So initial velocity y is equal to 12 meters per second. Okay, I guess I could buy that. And this is 3. Our cap, I didn't get the displacement. The left is 846. Our x is going to start at 842. Wait, hold on. This is problematic because this is in meters, and we need to be in pixels.
True.
So we're going to say meters
Can't
to
mix the
pixels.
units.
Yeah, that's why we only moved a little bit. So that cap x is off by a bit. That could be the problem, that it's just shooting it far away. Cap y is equal to 1080. That all makes sense. Can we
rerun that?
I don't
drag the arrow up higher. Or?
I don't know if we can or not. I've never been able to do the things I can do in C# and in JavaScript.
That's a shame.
Yeah, so that's too bad. We can't fix that. Can we change it here though? No, I don't think we can. I guess we could. I'm wondering if we could do this.
We could do a watch on that and then take the value and just jam it in there.
It's almost, let's see if we can get it. Where is it? Down here. So 650 is what it should be. So let's try doing that and jamming the value into this .cap x. Come on. 650. Nice, that worked. Okay. So then end cap 1 is there. And it's at 650, 1080. Okay, good. And cap 2 is at 650, 1080. Good. That's what we're expecting. There's our now time. Change velocity, both to 0 and now. We're still flying. And did I set? Yeah, I said still flying to false. We're going to push the cap, and then we're running. So I think we're just going to hit F5 till we get in here. And we're going to call update position now and now. And I think because the time has changed sufficiently, let's see what NCAP's at. Seconds passed. Wait, it's at 876. It looks like that might have been all that was needed. 876, 1083. Oh no, it's down under. It's down under now, is what it is. 1083. Hold on.
That's increasing.
We're dropping it down. We want to drop it up. We want to shoot it up. That's my problem. I had positive numbers there. All right, so let's run it. Okay, I'm just going to keep running it. Running it. Okay. All right, so now we're running. Now we're here. Now let's refresh and try one more time. I bet it works now. Do we have a breakpoint still in the up at the top? I want to make sure I don't have a breakpoint. I do. Let's kill that. Okay, so now let's try again. We've got to refresh. Let's send out the test wall. Test wall. And let's scroll so we can actually see it come up. All right, here comes the command.
Hey,
Nice.
that is much better.
That's what we wanted to do. That's totally what we wanted to do. And there was like, there were two balls being thrown because we had them both in the same position. They looked like they were slightly off as they were being thrown a bit, but that's the essence of what we were trying to do. All right, so let's do this. Let's give away a copy of CodeRushed.
That sounds like a plan.
You know what time it is?
It's time for the
Code Rush giveaway!
Today's winner is
Noah Golang.
Noah Golang. Noah Golang, congratulations. Real McCoy.
You get a copy of CodeRushed.
Right, Real McCoy was yesterday's winner. Real McCoy showed up right at the end in the chat room. I was like, whoa. So, yes, congratulations. I will DM you with instructions for how you can get your copy of CodeRushed. With that, I'm going to say goodbye to Rory, but I'm kind of inclined to see what else I can do here to kind of clean this up and keep going.
I will see you tomorrow then.
Thanks, Rory. Appreciate it. And
Have a good
we'll
one.
see you tomorrow.
Catch you soon.
All right. By the way, I'm going to be at TwitchCon this weekend, so in San Jose, California. So if any of you folks are out there, you can DM me on Twitch to contact me, or you can talk to me through my Twitter handle there at MillerMark, and we can meet up if you're interested. Let's see. Hold on. All right, so what are we going to do next? I think I want to do like a cleanup as well. I want to look at it again though. So, and the problem is I don't have a great way to look at it to clean up the screen quickly. Right now, to clean up the screen, I have to switch over to another view like this one, and then come back over here. And so that takes a while to refresh and reload it because of all the resources we're loading. What I want to do instead is when we do a doc command, is I want to clean up all the walls. And let's see what it is. Here. And self-destruct all drones is one of the things that we do, but I also want to remove all walls. Like that. And let's go declare that. Let's put it nearby this function right here. And I think that's good. And we have all walls. And do we have what was it? So there's a destroy all by, and we will get a, sure, why not? We'll do 3,000 milliseconds to do that. We'll call on remove all walls. And no announcer. There should be an announcer. Is there no announcer right now? Oh, you're right. There's no announcer guy. Hold on. That's because we ran and we had the errors before. All right, let's shut down and we'll restart up. Wait, actually, I think I can separately start up Mr. Announcer guy. Hold on one second. Let's see if this starts. I'm getting an authentication failed error is what I got. And I wonder if that is connecting because I've got a second thing already trying to connect to it. Let's try this. Let's try reset. Again, we're going to do a hard reset and try and bring this whole thing back in here. I think it was the... okay. So that's down. Let's kill Chrome and try one more time. And this will bring Mr. Announcer Bot back, I believe. All right. All right, so there we've got that running. Mr. AnnounceBot is in the house. So Will, thanks for that. I think we're back is the answer to that. We can do a quick test.
Fixed!
There you go. So Mr. AnnounceBot is in the house. Okay. Let's see. Destroy all buy. I want to just take a look at destroy all buy. Then it says destroy buy for the sprite and gives it an expiration date. And where are we checking on this? Still alive is the question there. Get alpha. And then we figure this out right here. Fade out time remaining. Fade out time. Oh, that's interesting. That's a 4-second fade out time right there. So, okay, we just fade them out, I suppose. All right, if that's the case, though, I want to change destroy all by, give it 4 seconds to get rid of itself. So, I don't know, we'll do that, and we'll see how that works. So, let's do a refresh, and I'm not sure if I've done that yet. Let's do it. It's loading, overlay is loading. Get ready to send the test wall command out. Here it is, it's loaded. Here comes the command. Yeah, it's not bad. The vertical wall is off in terms of its positioning, it looks like to me. It looks like I've got a mistake in the logic for vertical walls. In fact, these balls should be right over each other as they come in. Let's go ahead and do a launch followed by a dock and see if they go away. Okay, not bad, but then we've got the floating, we've got the all walls destroy all by. Let's see if we can also get these to destroy their, so removing. That's if it still arrives. Sprite splice and sprite dot removing is our opportunity to do something else on there. The wall is extend sprite proxy. That means we can hook into removing is what we can do. So let's hook into removing. And we're going to say, what is the, I'm not sure what the, let's call it super dot removing. There's nothing. Okay, there are no parameters on it. Okay, so there's that. It's a void. And here, I think we're going to say, go to the end caps, sprites list, and choose remove. Do I have a remove? Remove expired sprites. Let's just see what that looks like. I want to look at the code inside there. It's just like gets its index. I could just do that. Okay, let's do that. Let's say end cap, hold on. End cap 1 dot expiration date equals now. So the expiration date for end cap 1 is now, and end cap 2 is now. So they're expired. And then I can come in and say end caps dot remove expired sprites now. +1. Okay, So that I think might be good. And then we can, let's call super.removing as well. So we go up to the super class. See what we get there. And let's see if that cleanup is a little bit better. What was it? The other thing that was interesting is with the horizontal wall, I noticed that the horizontal line immediately disappeared, but we still had animation and it was fading out over on this side. So I'm not sure what was going on with that. Let's see what happens when we redo this. So we'll say test wall, and maybe an expire after time milliseconds function. I think I have that. I think I have something that I thought I had that. What's happening is the expiration date. Hold on. Hold on. Oh, I think I know what you're saying. I totally think I know what you're suggesting. You're suggesting that we follow this path down, destroy all by. Destroy by, that's what we have. So destroy by, boom. We can do this. This may be a faster, better way to solve this problem. So we're going to go into our wall descendant here, which looks like it has some error somewhere. And we're going to override that expire by. Destroy by, and we're going to call super dot destroy by, passing in the lifetime milliseconds, and then that's going to set our expiration date, and then I'm going to say this dot end cap 1 dot expiration date equals this dot expiration date. That I think is like a better fix for it. And I think we might still have to do this, but we can just come in and I think we can just do this. Well, wait, this ensures that they are absolutely going to be removed. I think we'll keep that code. So we'll just make sure those are cleaned up. I'm going to try that and see how that works. All right, here's the load. Here comes the test wall. Not bad. Let's do a launch. Let's do a dock. They both faded out. One seemed to fade out faster than the other, but they appear to be cleaned up. If I would come back out and do a test wall again, yeah, the vertical's definitely in the wrong position. Let's figure that out. see where our logic problem is here. The vertical. It was like it was up too high. Let's look at this logic again. So if the orientation is horizontal, there's our x represents our center point, minus the end cap sprite width, half of the sprite width. That's x, and the top is, oh, the final cap top is right there at y. That feels like that's wrong to me. Feels like actually we don't need a check-in anymore for these. It feels like this is the code we need. And we just need this and this here. I think whatever we had before, we didn't need it to be so much like that. Let me do one other thing here. Let's go. No, I want to crop the image here and bring this like that so it sits more on the line. Okay, cool. All right, so let's go with, let's try that. See if that gives us 2 balls that are right on top of each other as it comes up. Okay, so we're reloading. Here's the test. Nice. Oh, nice, except for it was too high when it landed. Hold on. Let's launch. Let's dock. Yeah, the speed at which these are going away is different too, but it's okay because I actually want them to close up when they go away. So, but I just need this. This is like a temporary fix for now. Let's see. Let's throw out the test wall again. Let's watch this carefully as it comes up. Yeah, it was too high. It was coming up too high. Let's look at it could be our logic too. Our height in meters is our final cap top, and I'm adding the sprite height to it. And then our Y is 1080. Here's my problem. It's this right there. I need to drop it down below the height, I think. Yeah, I think is that's the problem. Final cap top, yeah. Or I could just take this out of both of these, but I kind of like it being slightly off screen by its own height. But this, whatever number's here has to be here. Let's do this. And I think that's going to fix it, is right there. That'll fix it, and then we can later tweak this if we want to get it to, if there's any problem or delay. Should the flowers go away too? No, the flowers go away on their own. The paint goes away on its own. I'm okay with that, the way it is. All right, so let's refresh. And get ready to send that test wall command in, and it's loading, and there it is. Here comes the test wall. Boom, boom. That was so good. That was so awesome. Let's see if I can do a dock command here without it being launched, if it'll clean up. Okay. Yeah, but there's a bug in there which we should go look at and fix, where it's like it's toggling in the wrong way. Let's go look at that and see if we fix that bug here. So let's go look for dock. Okay. If started and chat docking, and then we're calling myrocket.dock, and docking, engines retracted, then extend the engines, changes rejected, docking is equal to true. But isn't there a docked already? Let's see. There's not a, there's a docked top and a docked left. Which we could start by setting those to true. That at the very least feels like nope, we've got an is docked. Let's just check that. Or are we checking it? My rocket is docked. I think we just do this. Like that. And then that's going to stop that problem, I think, from happening. And we may, that may be what we need to do. Started stock. Okay, let's try that. You killed my drone. I swear revenge. You can always start a new one. Okay. Here we go. By the way, just want to say,
Will Bennett rocks.
because he's very helpful and he makes this stream way better. Here it is. It's coming in. So thank you, Will, for that, by the way, as always. Let's test the wall. Let's bring that command out. Here it comes. Boom. Oh, my God. I love that. I love that so much. That's exactly what I wanted. I've been dreaming about that in my head. I've been envisioning essentially this, right? Being all the balls thrown up, the walls are forming wherever they go. And I've been thinking about that, imagining that for about 4 days over the weekend. And I was like, oh, I want to code it. I want to code it. Let's do a doc command here. And this should kill these without that other side effect, which is good. And then we can come back and test the wall again. Nice. Nice. I'm like really happy with that. I think what I'm going to do is I'm going to call it a show, even though I'm totally motivated to continue going, but I'm like, I've got other things that I've got to do. So I'm going to move on to those tasks, but we're going to see you tomorrow. Again, thanks to Will Bennett. Thanks to Z Doctor for showing up. And thanks to everybody else who's been having fun with this. And we will see you tomorrow.